Thank you for being here. My name is Moonlit. I lead cross-Google partnerships in gaming. Today, I have assembled a panel of amazing leaders in gaming and GenAI. I'll have them introduce themselves, and then we'll get started. All right, Jack, let's start with you.
Sure. Hello, everybody. My name's Jack. Been at Google for just over 8 years now, and I've been in the games industry for over 25, believe it or not. So I got my start way back in the 90s, and I couldn't be more excited to be here today and talk about generative AI and games. So welcome.
Hi, everyone. I'm Lei. So can't beat Jack, the 25 years veteran in gaming. But this is my 12th GDC, so that's pretty good, I think. So I'm with Google 8 years. I'm in Google Play, and I'm taking care of partnerships, in particular working with GenAI native devs and also helping apps and games developers, folks in this group, to figure out AI use cases. So look forward to chat with you.
Hi everyone. I'm Simon. I'm a PM director here at Google. I work in labs, and I also lead post-training for Gemini. We're seeing so much amazing take-up from across the community with our latest models, and I'm especially excited with all of the cool things that are happening in the gaming industry. It's actually my first GDC, although I'm a massive gamer, starting out with ZX Spectrum, like Chucky Egg, all the good stuff, through to clocking up over 100 hours on Hades, my personal favorite. Looking forward to Hades 2, hoping for it soon. Look forward to chatting with you all today.
All right, thank you, all of you. And thanks, everyone, for being here. So in the next 20 minutes, I will explore how GenAI is going to transform the gaming industry. I will cover 3 things specifically. First, we'll talk about how Google's AI and GenAI solutions can help with game development and publishing. Second, we'll talk about how you help transform real-time in-game experiences. And last, we'll leave you with something on how you can get started. All right, let's get into it. Jack, let's start with you.
Sure.
From Google Cloud, what could AI and GenAI solutions do for game developers in terms of game development and publishing?
Oh, great. Great question. We have made some announcements recently around a term called living games, which describes sort of a new generation of games that we expect to come onto the market over the next few years that incorporate many of the fundamentals that we've seen in live games or live service games, but now underpinned by generative AI. So if you think about the cycle between a game and a player traditionally, when our industry was primarily consumer packaged goods, the developer would build the game, and then the player would play the game. Enter in live games, and now you had a cycle between the player and the developer so that the developer could create new content based on the needs of the player. With living games, you actually have generative AI as part of the game so that the player and the game can communicate directly to each other, and the game can update itself so that it can respond to player behavior much more rapidly than a traditional live service game. So we expect these games to start to come onto the market in the next few years. In the meantime, we'll actually see generative AI enter first in the context of game development. So we've seen a number of developers that we're working with now that already have generative AI inside their production pipeline. So many of these developers are using a tool that we have at Google Cloud. We call it Vertex AI. And this is a managed platform for AI and generative AI. So it basically has all of the tools you need to safely and securely select the right generative AI algorithm and then tune that algorithm on your own data in a very secure way so that you keep your data safe as a game studio. We also work with very sophisticated game developers as well that have gone so far as to even develop their own LLMs. So recently we announced that we worked with NCSoft to develop their own LLM called Varco, which they intend to use for development as well as in-game experiences, which I'm sure we'll talk about later. So it's actually becoming quite common, and I think you'll see generative AI actually take root first in the context of game development. In fact, it's pretty common now to see generative AI in the context of game development, even if it's just for concepting. But I think where this gets really exciting for the player is when we go into the game itself, and I'll save that for a little bit later.
Thank you, Jack. Lei, anything to add from publishing perspective?
Yeah, great. So just to follow on what Jack mentioned, this paradigm shift from packaged goods to live ops games or live games to living games. We see that also transformation in the game publishing or distribution space. So the Play, first and foremost, is your game distribution on mobile, on Android platform. However, we are also moving from a distribution to covering your entire life cycle for both games the developers and also gamers. So in that sense, so we are also the user, first and foremost, of GenAI, right? So we use GenAI to enhance game discovery. We use the GenAI to enhance developers, you to create your marketing assets that's on Play Store. So if you follow the development like we announced over GDC, so there are some very key enhancement of how users can discover games. And the AI-generated content, including FAQ, including summary of your content, you don't need to generate yourselves, right? So even in the foreseeable future, your store description and probably your graphical assets, right? So can be generated, right? So with GenAI. So this is something that's super exciting. And on the other hand, so we do also observe, so in these two areas and also maybe two steps, first, game devs use GenAI to enhance their workflow, right? So from concept arts creation to translation to localization, we'll get into more detail later probably. And then also probably more excitingly to see the new game experience, new user behavior, right? So coming out of adopting GenAI for gamers. So Jack mentions so the games will be live, so will be living, will be connecting user and developers all the time, right? So we do see also in the progressive way of using GenAI to create smarter NPCs at the starting point, and then assets, graphic assets. Not only for concept art, but really generated live, right? So we see that in some games. And probably the next step would be truly generative games, right? So I think the industry is also taking these steps, right? So from completely transforming the production process to transforming the user experiences or gamer experiences. So.
Before that, do you have any examples you can share, case studies?
I can probably mention for both, right? So. Some APAC IPs in particular, Japanese IPs, and some from other part of APAC. So they are very popular regionally, and so some developers. So they are using GenAI to transform some of the IPs to be more inclusive and also to be more suitable for other markets, right? So I think that's a fantastic use of GenAI. And on the user experience side, so I would recommend the one just just impressed me the most is one game dev called Hidden Door. So you can look it up. So they do create this amazing capability of user to choose a theme, say say Sherlock Holmes. Right, so I can create a Sherlock Holmes themed RPG. Right, so with graphics, with story, and it's truly personalized. And so this is something in the gamer experience side.
Cool. Thank you, Lei. Simon, what about you? What are from labs?
Yeah, there's so much opportunity, I think. So obviously, generative AI can help any business become more efficient and do more with less. And the game industry is full of businesses that are trying to compete for gamers' attention, but also operating under really strict timelines, really strict deadlines, and often under really strict budgets as well. And so fundamentally, I think GenAI can help across the board when you look at the business. But just focusing on the creative side of things for a second, Jack, you mentioned the ideation and the creative flow. So we put a lot of our cutting-edge models up on our labs portal, and there you can access text effects. We've got music effects. I think there's a couple of there's image effects. There are more coming as well. You might imagine what they might be, given the FX tag. But these are all tools to help with the creative flow. So we've worked with artists, for example, in text effects. We work with Lupe Fiasco, a pretty famous US-based rapper, to explore kind of linguistic flow and kind of explore new creative ways of chaining words together to communicate, simile and metaphor and all this kind of thing. And you can definitely imagine how that might be useful if you are working on a particularly creative game. Same for music effects. We work really closely with Dan Deacon, who's a pretty famous electronic musician, to help him with kind of live performances. So this is a music tool that allows a musician to change the flow and the tone of a live performance, and have a kind of an AI composer next to him or next to them, like creating music during a performance. And this we found is really useful, especially for anyone who's trying to explore new vibes, new feelings. And so a good example of a tool you might use in the kind of the early stage of ideation to come up with a kind of a new feeling or a new concept for a musical accompaniment. Moving away from those kind of, I suppose, like smaller, more focused models and just focusing a little bit on Gemini, we released Gemini 1.5 a couple of weeks ago, about 3 weeks ago. The key thing with 1.5 is it has a 1 million token context window. And so if you've ever worked with a large language model, and I guess all of you have done that before, you'll know that the context window is really the thing that kind of limits what you can do with these things. With 1 million tokens, that's kind of the equivalent to like all of the text messages you'll send in a lifetime, or all of the emails you might send in 6 months to like a year period, maybe a bit less if you're at Google. You know, there's a lot of emails here, but like a lot. And so, you know, if you're trying to, for example, you know, and also that like these tokens don't just represent text; they also represent multimodality. So that also equates to, for example, like half an hour of video. Right, so you can upload half an hour of video to Gemini and ask it questions about the video, or ask it its opinion on things, or ask it like, well, what should happen next, and so forth. It's about, I think it's like 3 hours of audio that you can get up there as well. And so we found this to be really useful, like in a range of different cases. So we found some developers uploading 50,000 to 100,000 lines of code, 100,000 lines of code, and then taking a video of them interacting with some UI bugs and asking Gemini, hey, can you just fix these bugs for me? I've uploaded the code, I've uploaded a video where I'm demonstrating the bug, fix the bug, and Gemini outputs the code that fixes the bug. Right, so that's a clear win for anyone who's been struggling with any kind of UI issue, which I've definitely been victim to in the past. There's lots of other examples like this with video where we've found people trying to sort of catalog things like catalog bookshelves and all this kind of stuff as well. But I would say, the opportunity for Gemini 1.5 to really ground the model in your game's universe, for example, if you're in a particularly creative mode, or if you're kind of more on the operation side of the business, and you're trying to ground Gemini in, for example, your customer support manual, or an FAQ, for example, for a game. The models are finally able to actually maintain that entire context and use that to generate a really cogent response. And if you've ever tried to do sort of RAG-based solutions for doing information retrieval, you'll know that that's like a major issue and a real challenge. So I'm really excited about kind of the models where they're going from the perspective of creating new things. And although we're at 1 million today in research, or in the lab, we've got Gemini operating over 10 million tokens, which is a whole lot more, and we're aiming to continue pushing the boundary there as well. So yeah, hopefully this should mean better tools for everyone who's making cool stuff with AI.
Thank you, Simon.
If I can just add one more example to amplify this 1 million window, why this is so exciting. So like the personal experience, I mentioned Sherlock Holmes, right? So it's not random. That's just my favorite novel and favorite story. So I try to use a custom bot creator to create a RPG, text-based RPG based on Sherlock Holmes previously, right? So it wasn't very successful. It was like, yes, it's a playable sort of playable game, and it used the Sherlock Holmes theme and 19th century London, and why not? But really, it's not using the detail or the concept or the story itself, right? So, and then with this 1 million context window, I uploaded. So, by the way, so you go to aistudio.google.com. That's the no-code a tool you can really prototype such things, right? I uploaded the entire Sherlock Holmes adventure, right? So, and then I asked it to create just a sample story or you can call it a game, right? A scenario, right? To connect and with details of a particular story, right? So, and that really worked, right? So I think that's amazing, right? So not only the context window, but also the precision, right, to pinpoint to specific details, right? So of a very, very long text in this case, I think these are just amazing use cases, not only for like capture my lifetime's text, which is an apps-specific use case, but for games as well. Yeah.
Thank you, Lei. We actually have 5 minutes left.
Oh boy, that was fast.
Just very quickly, switching gear to in-game experiences. Jack, you talked about a living game concept earlier. Can you share more on how AI can elevate real-time in-game play?
Sure. I think ultimately games will be able to respond directly to players' implicit or explicit instructions or needs and desires, if you will. The game will be able to create content on the fly to immediately meet the needs of an individual or even a small cohort of users, and you'll see something coming very soon from my colleagues at Google on exactly that. I think that games will have NPCs that are fully organic, and they're able to have natural conversations using real voice or text with the player. They will be able to stay within the context of the game, but also respond in a wholly original way each time, and something that feels very unscripted. I think that the boundaries are limitless, frankly. I think soon we will start to see games that are foundationally built on the concept of generative AI. I like to say, when we talk about living games, I think this will be a technological revolution on par with what we saw with 3D graphics or even the CD-ROM. And if you think about how those technologies rolled out into our industry, you started to see more traditional game types take advantage of the medium, but around the edges. But soon you started to see games like Final Fantasy VII or even Myst that simply couldn't have been built without the CD-ROM. And similarly with 3D graphics. I think the exact same thing will start to happen with generative AI. We'll start to see games come to life, but then you will have fully living games that literally the game design could not exist had there not have been generative AI as part of it. So as we move into this world, I do like to point out a couple examples of some early living games that are starting to come to light. The first I'd like to point out is from a company called Hyber. And if you haven't checked out what Hyber has done, they've created basically a 3D world generator. So think of this like almost like a user-generated content platform. However, they've just rolled out in alpha an AI assistant, where with natural language, you can just tell their platform what game you want built, and it builds it. So this is explicit requests from the player, but soon you could imagine, because we know so much about our players, we have our analytics platform fully up and running, we could actually feed that directly into a generative asset pipeline. And games could start to generate content based on the implicit actions of players, right? So the player doesn't even have to request something, it's just the game knows what they want, which is pretty impressive stuff. Second one I'll point out, it's not so much a game, it's actually a partnership that we announced at Google Cloud recently. It was with a company called Replica Studios. So you may have seen Replica Studios in the news recently with their deal with SAG-AFTRA, the Actors Union. They have been able to create fully organic, natural, intelligent NPCs using generative AI. And these characters are fully voiced, again, using AI, and can have very natural, organic conversations in the context of the game. They can even talk to each other, which is pretty cool to watch. And so we couldn't be more excited to partner with them. If you haven't seen the latest video that they just put out, I believe it came out on Monday, it is really, really impressive stuff. It just scratches the surface of the power of this technology. With all this said, there's a lot of options out there with generative AI when you're thinking about either development or especially living games. There's a variety of models out there, so I do encourage people to check out Vertex AI, because there you'll have access to Gemini, you'll have access to other models from Google, but you'll also have access to over 130 models from other third parties, right? We've even done a deal with Hugging Face. You can have access to over 100,000 models on that platform. So it really, at Google Cloud, our message to developers, definitely we love it when you check out our stuff, but also check out our platform, because if you find that the Google models aren't exactly what you're looking for, you'll have access to all kinds of other stuff, but also have the benefits of that managed platform, which keeps your data secure and allows you to tune these models as you see fit. So there you go, living games.
Thank you, Jack. Lei?
Fantastic. To echo Jack's living game theme, and as well as the progression from NPC and using, say, Midjourney, Stable Diffusion to create assets, to create assets on the fly, to eventually generate fully generative games. I think I can probably provide one example of developer in the middle. So encourage the group to check out a developer called Spellbrush. So Spellbrush, indeed, they're the team behind Niji Journey, which is also a sister team of Midjourney. They indeed already introduce not only, again, so using text to image to create assets for game creation, but also enable this to gamers. This particular game is called Aeromancer, so you can download it from Play Store. So it allows users to create custom assets. In this case, basically like cards, you can imagine, right? So these will be fully personalized and like very different. And as you can imagine, so there will be potential commercial opportunity associated with that. So this is just a one step toward the truly living game and fully generative game and somewhere in between. So definitely check it out.
Thank you, Lei. And Simon, we'll end with you. We got 1 minute left.
1 second, yeah. Okay, I'll keep it quick. So I'm really excited about the living game concept overall. Latency is a thing that we are continually optimizing to make it more possible for you to leverage these technologies in real time in games. I would say, there are models right now that are probably usable for in-game, but there's still a lot of ground to cover, I think, before we really unlock the power here. I'm especially interested personally in kind of the NPC or the other character side of things. For me, gaming really transitioned. It made a massive transition when multiplayer, came around. I have fond memories of like Dust or Phantasy Star Online on the Dreamcast, and that kind of like opening of the world up through multiplayer was something that I still hold like very dear to my heart. With the new technologies that we have coming in, we can create much more believable either NPC characters in-game or additional players for you to either collaborate with or cooperate with or compete against. And these are things that are especially interesting to me. When I think about multimodality especially, the new models have vision, so they have the ability not just to be kind of like puppeted models that are just talking to you via an LLM, but they also have the ability to see and perceive the context and the environment around them, and to be much more believable, when you interact with them in game. And you can imagine the same is going to come for voice and audio and so on as well. So I'm particularly interested in making games just feel much more human, much more alive, much more complete, especially when you're in a single player or in a few player kind of context.
Cool. Thank you, Simon. Minus 1 minute.
Sorry.
So, Jack, you mentioned Vertex AI. What about Gemini? How can people in the audience get started?
Yeah, well, we can go to the one slide we have, I think. So if any, this was actually on screen when you all came in, but if you want to get access, we've got a team at Google that's actually taking everyone who signs up at aistudio.google.com today off the list immediately. We're on the lookout. We know you're all here for goodies, and while we do have a kind of a normal wait list, we're accelerating taking people off today. So if you want to try 1.5 Pro with the 1 million context window, go sign up here. The API is also opening today. It's not been announced, but we are starting to take people off the API too. So if you're interested in getting access to the API as well, go here. And really, like, AI Studio it's not something that you want to be using in production, but it's something that you can definitely use quickly just to kind of get a feel for what the models can do. If you like what you see and you're excited to develop more, I definitely recommend you contacting folks in cloud who can offer a much more kind of stable managed solution.
Well, awesome. I think we are at time. Thank you, Simon. Thank you, Lei. Thank you, Jack.
Thanks, everyone.
Great stuff.
All right. Next, I'll pass it to Glenn to talk about Gemma, our open models. Round of applause for Glenn.
All right, so let's dive straight into the core of this topic today. Like, what exactly is a large language model? Well, essentially, it's a type of artificial intelligence that's built on something called an artificial neural network, which is inspired by the way that the human brains operate. These LLMs are huge. They have billions of digital neurons, and these neurons aren't static. They learn weights or numbers through a process called training. They're trained on vast amounts of text data, and they actually learn to predict the next word or token in sentences. So if I were to ask you to bake a cake, if I were to ask you to complete the sentence, to bake a cake, you need lots of blank. You would probably say ingredients, and that's exactly what these models are doing, but on a much bigger scale. And you can imagine you need to have a lot of context, a lot of knowledge to actually fill in that blank. So it's kind of amazing that they can do that. And so these type of models are called foundation models. And these are kind of the basis that can predict that next word, but they can be tuned to do things like follow instructions or chat or things like that. And generally speaking, the larger the model, the more capable it is of understanding these complex requests and having more like accurate and nuanced responses. So you can use these LLMs today as a creative assistant via chat interfaces. So they can help you suggest new themes for your games, mechanics, help craft original content. They can be your inspiration engine, get you past creative blocks, especially when you're fleshing out quests or character stories. And they can be your collaborator. You can pretty much ask them anything. They can help you come up with ideas. So these things are really transforming the way that developers approach game creation, especially in the early stages. So text-to-image models can be used to visualize characters. So you can imagine you have an idea for a character. Maybe it's like a wizard that likes to cook and it's like in a desert. You can just write that in and the model will give you an image of this thing. I actually worked on something like this. It was called Flip.io last year, and it was a card game where we used generative AI to create all of the card images. And so we used a technique called Dream Booth, where it's kind of a fine-tuning technique where you can teach an image model about a new character. And we used our like Android character, our Flutter character, and had like made a bunch of really cool images. And you can get that game on the app stores. You can also like generate backgrounds. Now you can generate 3D images from text. You can generate videos. You can do a lot of stuff. And so also, like for development, you can make them your code assistants. So you can type in, like, I want a function that does this and that. I need it in Java. And it'll give you like a skeleton and start that function for you. And a lot of IDEs actually have code completion. So you can start writing your code, and it'll complete it. And if you want to just have like placeholder text, it can do that really easily too. You can use these things as your world building assistants. You can use them as your lore keeper. So imagine that you want to like track all the details of your lore. Well, Gemini 1.5 can remember like 1 million tokens, and as Simon said, that's a lot. So it can help you like ensure a seamless, believable narrative experience. But the thing that I'm most excited about with these LLMs, and it was mentioned earlier, is like the dynamic dialogue. So with this, you can give an NPC a prompt and tell it like what it is. Like you could say you're a wizard in a cave and you have a sword and you're willing to give this sword to any traveler who might find it handy. And then the NPC will converse in open-ended chats with your players. And this will be pretty cool. Like it'll say things that aren't scripted. It'll say things that your player's not expecting and just be more immersive. It can even remember like past conversations with players. So maybe something was said yesterday. It'll remember that, and it'll take that into consideration. And maybe if a multiplayer game, it could remember like what someone else on the other side of the world said, the day before. That's kind of amazing. You can imagine like what kind of experiences you can create with this. So it just makes them feel more responsive and alive and less predictable. But with great power comes great responsibility. These LLMs, they're trained on this massive amounts of data, and this data has a bias in it, and it has toxic content in it. So these things can actually make biased content, can be kind of dangerous. So you need to be careful when you deploy these things. You need to make sure you're monitoring them, make sure that you are taking care of that, because there are a lot of like reputational and financial risks that you could incur if you don't do that. So we have two kind of model families. We have Gemini and Gemma. Gemini is our family of most capable models. You can access these via an API in Google AI Studio or Vertex AI, and these are really good models. And the thing that I work on is called Gemma. And Gemma is our family of lightweight, state-of-the-art open models, and they're built from the same research and tech used to create the Gemini models. And these have a commercial license, so you could use these in your games. And they're all designed with our AI principles at heart. So why Gemma? Well, Gemma comes in two sizes. It comes in a 2 billion parameter size. And this is cool because you can run this locally on a mobile phone or on a laptop. You don't need to do any kind of cloud calls to run this model. The 7 billion parameter models are biggest, and this requires like a NVIDIA 3090 GPU or some kind of desktop gaming GPU, but turns out a lot of gamers have good GPUs, so you could tap into this. So that's pretty exciting. And then customizability. So there are lots and lots of, we only launched this thing like a month ago, and there are already like tons of different open source code examples that the community has built, so you can do all kinds of neat things with this. And something else that I think is interesting is like, imagine that you like have a game series and you have like many different dialogues from the past. You could compile that into a data set and fine-tune this in LLM to actually speak in the style of your past games and speak in the style of your past characters. So you can build pretty neat things with this. And then there's a huge community around both Gemini and Gemma. So you can reach out to them, you can get help from them, you can share knowledge and ideas back and forth, and we have lots of tools that kind of can make that learning curve easier for you. Last but not least, we have this responsible AI emphasis. So with Gemma, we have a generative responsible AI toolkit. We're working on that name to kind of shorten it. But this can help you put guardrails on your content to however you prefer and just help you ensure a safe, enjoyable experience for your players. So one of the cool things about Gemma is that we launched it in all of the major libraries and frameworks. Like usually an open model will launch and it will be in like one, but we launched it in Keras, TensorFlow, JAX, PyTorch, Hugging Face, have all these cool things. It even runs on your CPU. So we have Gemma C++. You can run this thing as a binary on your machine. And there's lots of tools to make it easy to deploy on Google Cloud. And so this is an example of how easy the Keras code is. So the first line here, it is calling the Gemma 2 billion parameter model. The second line is sending a query to figure out what the meaning of life is. And the third one is just printing the response. So you can see like for a 2 billion parameter model, it's pretty good what it can do. This is just a screenshot of Gemma C++ running in the terminal. And this is a cool game that you're going to maybe see in a little bit. And if you want to get started with these things, you can go to ai.google.dev. There you can find Google AI Studio, links to Vertex, and more about Gemma. And I will be on the second floor for the rest of the day at the Google for Games booth if you want to chat about this stuff. And with that, I want to hand it over to my buddies, Dan and Giovanni. We're going to share some pretty exciting stuff. Thanks.
All right. Welcome to the last part of this three-part series here. So we're going to focus on generative AI for living games, just as Jack mentioned earlier in the panel here. My name is Dan Zaratsian. I'm the tech lead for AI and ML gaming solutions, and I'm here with Giovanni.
I'm Giovanni Mora. I work with Dan. I'm a hybrid specialist and app modernization, only for games. Nice to meet you all.
Okay, so here's the setup. We're going to first go through a little overview just to orient you all on what we have on Google Cloud. So as they mentioned earlier on the panel, there's a couple of ways to get access to some of these models. We're from cloud, and we're going to be focusing on that, especially from a productionalizing and getting it into your games. Then we're going to talk about the architecture. We're going to show a demo recording that we have. And then we'll kind of talk about some of the things that we're thinking about next and lessons learned and things like that. Okay, so from a framework perspective, just to orient you a bit on how we think about generative AI on Google Cloud, there's a couple different layers. So the first layer at the bottom is going to be around the infrastructure. So in order to make this work and scale for your games, we need high-powered, scalable, global scale infrastructure. So that's number one. On top of that, we have the actual models. So we have Gemini. You've heard quite a bit about that already. But as Jack mentioned earlier, we also have several other third-party models that are available. So select whatever works best based on your use case and needs, and then run it on our platform and scale on a managed platform that's all secure and allows you to fine-tune or ground or whatever you need to that particular model. On top of that is the framework that allows all of that customization, mostly in what we call Vertex AI, which is on Google Cloud. And then lastly, you build your game on top of that framework. So from a structural standpoint, this is kind of how we're thinking about it. There's lots more that goes into it, but this is a nice visual, hopefully, that you see the data coming in. You see a safety filter that we think is very important, both for pre-processing some of the data, for checking, are you getting anything that maybe is unsafe or you don't want to pass into your LLM. Then going through the pipeline of, certainly hitting the LLM, checking for grounding. Do you need to send the data to embedding its database, pull back relevant information, feed it to the LLM, maybe even integrate some additional data into that pipeline, and then sending it back out to the user. And again, the outbound request goes through the safety filters. So anything that we need to check for, grounding, are we ensuring that there's no hallucinations or any additional safety filters that we want to add in there. There's some built into our pipeline already that you can just take advantage of the metadata that's returned. And then other times, we'd also recommend, just as a general recommendation, that you also put in your own filters there, right? So check for, is this valid? Do you even look up against other data that you might want to ground against? Okay, so there are many things when Giovanni and I and many others on the team are building out these architectures and working with many different gaming studios. We think about certainly bias, certainly safety, ensuring proper grounding. Is it fitting into the storyline and doing what we need to? How do we balance the performance and cost? So these are some of the things that we're thinking about. We're not going to read through all these here. But these are just a few that we think are top of mind. And I know Giovanni is also thinking about some of the cost and platform aspects. So you can mention that.
No, it's just a comment, a small comment here, because we always have this trade-offs when we're talking about infrastructure, right? Like a cost versus reliability and all those things. So one of the examples that we'll show here, it's exactly to how to best serve in that, mainly related to this interoperability between open models and managed services.
Yep. Okay, so now for the demo. A little setup. So we've been working in a variety of games. We're not front-end graphic game devs, so you're going to see some things in here that maybe aren't perfect from a visual standpoint. But we've integrated NPCs into this game. We're going to, in a moment, play the video and kind of walk through that. But the idea is smart NPCs, just like you heard from the panel and from Glenn earlier. We're going to focus on that aspect, but then call out a couple features that we think are important from production level, global scale, and also even some tricks for the LLM that you might want to consider when you implement these. Anything else you want to add?
This is the architecture that we are using on this demo, right? And just to have an idea, we are trying to point a bunch of different things, so multiple ways to connect, right? Like a UDP connections, TCP, REST, gRPC, also security place, so DDoS protection, and right? To avoid this kind of problem, mainly talking about the external world. And then we are running this inside Kubernetes with the power of GKE behind the scenes. So with GKE, you have a managed Kubernetes, so no pain with the control plane, with the management size, 4 dimensions of auto scaling. So it's really easy to scale and also to distribute all those workloads across the globe. On the first layer there, we have a game server. So just a small highlight here, but we are using Agonis to serve that. It's an open source game server orchestrator. And then just serves that we built, and just a highlight for our GitHub repo, right? And those microservices, I think it's just good to remember the last picture that Dan showed, because it's On the microservice layers, we will be adding all those, everything related to the responsible AI and also to double check this hallucinations and other stuff.
Yep, thanks, Giovanni. From the generative AI perspective, you can see that we have the central GenAI API that we're accepting all of the inbound requests. That kind of federates out to many other generative AI endpoints that we have for different things. So some could be smaller fine-tuned models that an NPC needs depending on the input path. Some might be for image, like text to 2D image creation. Or it could be a Gemini call versus open source call, and you're kind of balancing those trade-offs. So that's kind of why we've designed this architecture. As Giovanni mentioned, there's a GitHub link up there that we're trying to add reference architectures and examples in there. So take that. If you're interested in getting started and want to just kind of play with it and get up and running, you can do that. And then lastly, you'll also see that we're using Spanner on the far right-hand side. That's where we're storing our embeddings. And this is really important for very quick lookups of like RAG-based approaches, where we can not only retrieve relevant embedding information for that we pass into our prompt, but we can also integrate with other structured data and still get that global scale and fully ACID compliant consistency from a database that we need for games like this to serve a global community. Okay, demo time.
Cool. Let's start it.
This is a demo of our smart NPC, and it is powered by Google Kubernetes engine, as well as Spanner on the back end, which stores and retrieves some of the chat history and also the knowledge of the NPCs. And then, of course, LLMs are used to structure and respond back to the player. So what I'll do first is connect to our cluster. So we want to get the game server information. So I'll say kubectl get game servers. We're going to grab the IP address and our port here, which is 7322. And then I'll launch the client. Here's our IP, 7322. Start client. Okay, so now my player's in this environment. I can see some basic structures here that I can go check out. But maybe first, I don't know where to go. So I'll just say, hi, can anyone help me? And so I'll just see if I can get some guidance. And Blake responds. And I'm here to help. To find GCP bot, look for a small white robot wearing a Google shirt. Okay, that's helpful. All right, so now what I'll do, it looks like maybe I can come in here, and it looks like GCP bot's in the corner. Okay, so we'll go ahead and come right here, and I'll see if this is GCP bot. Hi, what is your name? All right, this is GCP bot, and it can help me with my GDC experience. When is GDC being held? Okay, it's being held from Monday, March 18th through Friday. Okay. Can you recommend a generative AI session? Can you recommend? Yeah, we'll go ahead and do that. Okay. All right, so recommends a session for me. It even gives me the time when I can go. And then we'll say, who is your best friend? Okay, my best friends are Dan and Giovanni. We've been friends for a long time. Okay, so very helpful. So first of all, one of the things to point out is that we were able to switch NPCs based on proximity. At first, we were talking to Blake early on, and then now we switched to GCP bot, and that's all based on proximity. The personas for the NPCs are powered by a backend database, which stores embeddings, and we can quickly retrieve those embeddings. And that's also how we're able to look up some of the GDC information based on the GDC catalog. So we stored that. we're able to query about different sessions and then quickly find relevant content and surface it back through our NPC interactions here. What I'll do now is I want to show a multiplayer interaction or how this could work. So I'll come in here, I'll paste the same IP import, connect to the client, and now we have a new player. So let's go ahead and go to the same area. I want to talk to that GCP bot, and you can see my player 19 still standing there. So what I'll do, let's first just make sure this is GCP bot. Hi, what is your name? GCP bot, very good. What other players, let's see, let's just do this. What players are you talking to? Okay, player 19 and player 20. So you can see that we have context. So just like in the human world, the NPC is going to gain knowledge. It's going to know who it's talking to. It's going to know what the other NPCs have said. So I can say, you know, has player 19 asked you any specific questions? All right, so see, it's very intelligent. So it's kind of learning. These NPCs are learning from the conversations that they have. They can quickly recall information based on the questions that you ask them. And just like humans, they can start to store both long-term and short-term memory. So NPC or GCP bot back here has an initial starting persona and information that it knows. It knows its name, it knows some information about GDC and the sessions, but then as new players come along, it'll learn and it'll store that information that those other players have shared, and those go into chat history. And so those are also considered potential information, but it's not maintained in the same way. So one is knowledge that is known to be fact, and the other is learned knowledge through chat interactions. Okay, so if I come back here, I do want to go over here quickly to Spanner and just showcase, you know, this is real and this is happening behind the scenes. So we have our Spanner database. This is our globally scalable database that supports SQL interfaces, but as well as embeddings and a variety of other things that is very powerful from a global scale standpoint. So what I'll do is I'll come in here and we can see that if I say select star from chat knowledge, we can issue this query. And then here are the questions that I just asked. So you can see the question that was asked and the response, who asked that question and who responded. So the first one is blank because Blake doesn't have a name in our database. It's just if you talk into the air, Blake will respond. But all the other NPCs do have specific personas when you go up and you talk to them. We also have our NPC knowledge and our GDC knowledge base. So NPC knowledge provides specific intelligence for GCP bot and Blake and others. And then GDC stores, so if I look at this here, GDC embed, this one stores all of the GDC information. So what is the title, what is the session date, a variety of things here, which we've used just for demo purposes as part of this NPC demo. So that's the demo. You can see there it's multiplayer game. Both players are in there talking to an NPC, and the NPC is learning and adapting to this gameplay. I will, for the sake of the demo here, show you one more thing. So if I come out here, we can run up the stairs. And now this is kind of neat because the proximity to the video will make it louder. Okay. And then if I say, hi, what is your name? TV bot. So now we have another TV bot, another NPC called TV bot, who is a Google Cloud expert and can help you with all of your Google questions. So just a fun ending to this with another NPC, but that is the demo for our smart NPCs, and thanks for checking out the video.
So on this architecture, as I mentioned, we are using Google Kubernetes Engine, our GKE, right? Mainly because our game server, it's running on containers inside GKE, and then we can have like a small latency, right? And we can have this interoperability or easy switch between open models. As you saw on the architecture slide, we have a stable diffusion there, so it's easy to switch, for example, from Vertex to a local open model and use that inside Kubernetes, right? Here's just some highlights, but flexibility. I think we are running on top of containers, so it's really easy to run anywhere without locking, easy migrations, right? And also easy to scale that globally.
Okay, for Spanner, one of the things that we wanted to call out with on the demo portion, but I want to make sure that we cover it, is having some sort of database that stores not only the chat history between every single player and NPC, but also is able to store the knowledge for thousands, hundreds of thousands of NPCs. So if you think about it, like doing this, creating a personified NPC is actually really easy. It's pretty trivial. I'm sure all of you can go out there and kind of create a fun prompt, and it'll respond in a good way. Storing that data and maintaining the memory, especially in ephemeral type services that are globally scalable, if you're running on Kubernetes or you have to scale up and down, you can't just pass in that chat memory or that chat history as part of every single prompt. You typically store it off in some sort of external storage and then retrieve it when you need it, when that player comes back, or whenever you need to recall certain information for that NPC's persona. So Spanner is where we're doing that. There are many embeddings databases actually on Google Cloud that you can use. We have very specific ones that are just for storing vectors and embeddings, and you're welcome to check those out. We also have Spanner here, which is what we're highlighting for NPC use cases. And then also BigQuery is another enterprise data warehouse that we have in Google that does support embeddings. Now, for performance in games, specifically for NPCs, we think that Spanner is a really nice fit because it does support storage of structured data, those embeddings, and we're getting really good latency and performance for our global scale when we deploy these. So you'll see that we have that, simplicity in SQL. So Spanner is a SQL database. Again, it has different modalities that you can store within it. And then there's also the cost savings aspect. And I don't know if you wanted.
Yeah, I think it's good to mention, like we didn't have the video here, but I think it's good to mention, right? So just walk through the demo. We have like it's a multiplayer game, right? And we use collision to identify the bots and the NPCs. And that's the main connection with the Spanner. One nice thing that we have on the demo, it's that like a context that Dan mentioned. So if I go to the bot and I ask something, the next player or all the other players will also have access to that context. So they can just ask, anyone ask you about a dog or about I don't know, anything, right? So that's a really cool interaction between the NPCs and also with the players, between the players.
Yeah, and it's important to call that out because just like with all of our interactions, when Giovanni is talking to me, I'll remember things and recall, and then I'll tell it to Glenn or to Jack or to whoever. And so we're trying to make these NPCs do the same thing. And in very large-scale games where you have many players, like a large player base, that chat history can become incredibly large, incredibly complex. And so that's why you hear me mention the embeddings. It's very important that we're able to retrieve those quickly and recall certain information that someone was told. Another thing I want to point out is that we also have this idea of the knowledge that you know to be true. So that kind of grounds your character in something that you know is relevant, and you want them always to recall, and you want it to be very truthful and factual and consistent. Then we also have things that the NPC learns. And so you could think of these as rumors or as like learned knowledge. And so that data is stored in a different way, and it's recalled back in the prompt separately. So that those two things are separate. You know there's ground truth that we don't want to touch, and then there's kind of learned knowledge that you can pass on to other players as part of our living games, but it'll be absorbed and kind of used with less priority than the grounded truth, right? Okay. Well, okay, so we've all been talking about a couple of the tools to use, some strategies, but what about scale? As we think of scale, how does that work? So Giovanni.
Yeah, we did a bunch of different tests about like scalability, reliability, and reduce the toil. So everything that we are doing on that Git repo, just to have an idea, we are using like a Terraform for automation. We are using a Scaffold for building and deploy things, and like we have like the whole pipeline, everything automated and easy to monitoring. One thing that we would like to show at the demo is the tracing piece. So when we add a tracing piece in all those microservices, it's really easy to understand the connection between the microservices and also to test it. So during our test, for example, we start using Vertex AI, right? Different response, and then, oh, we need to get more context, so let's add a spanner on that. But what now? What happened with the performance, the latency? So having this kind of tracing thing, it's really nice and good, maybe needed to understand all of your microservices and the relationship between them.
Yep. Okay. All right, so what's next? What else are we thinking about? I'll just mention a couple things and then pass it to Giovanni. So one is code gen. You've heard a little bit about that earlier on, but we're seeing a lot of if we speak more broadly than just NPCs, we're seeing a lot of adoption for generative AI for internal tooling and productivity. So it might be for code generation, making developers move faster, right? Even generating unit tests or finding bugs. So that's something that we're certainly seeing.
No, just a comment because it's really easy to use. I don't know, but you have like the cloud code module that you can add on your like a IDE, right? Yes. VS Code, for example, and it's really easy. Just open up a tab, select the code, and explain this, or how can I improve this, or help me with that to do the next thing. Yep. So it's really easy to use that code gen.
Yep. And the other thing we're looking into heavily, and I'm really excited about, is this idea about LLM agents. So if you think about not only passing in one prompt to one LLM, but what does it look like when you start to chain together LLMs to do different things? So if you can imagine a scenario where you ask an NPC something, like, hey, what is how much have I spent on games in the last month, right? Or something like that. That might actually go down a path where it doesn't actually communicate to another NPC that acts like in a certain persona, but it might actually send a background request to issue a query against a SQL database that knows your spend or transaction history. Or what if you want to ask the LLM something where actually on the back end it wants to fire off an API request to take another action that you have set up. And so if you think of chaining together these NPCs or these LLMs to do something very sequential and very powerful, I think that you can start to get a lot more out of LLMs than just a one pass back and forth to the LLM. So you'll see a lot more about that where the design of the LLM is either sequential, where you have several in a group, or you have these LLMs where they federate out to different endpoints. One hits SQL database, one hits API, one hits another LLM, and things like that. So we're really excited, and we're developing that and adding some more of that into that generative AI quick start that we have in GitHub. Giovanni.
Just another comment about this kind of scalability and global distribution, right? We are using, as I mentioned, GKE. We can also use it GKE Autopilot. That's easy to manage. But the service mesh, we are trying some stuff with service mesh, and it's really good from this game perspective because the service discover, so you have your game server and your game services, right? Your matchmaking, maybe chat and toxicity and other things. So how can I use maybe a central service, or how can I scale that between or around the globe, between regions, right? But keep the traffic inside that zone or that region. So service mesh will also help with that, but the highlight here is to decouple the network functions from your code. So sometimes we are developing the game and, oh, we need to do retries. Sometimes we have the endpoint out and we need to create a circuit breaking. Okay, can I do that inside my game, inside my code? Yes, I can. But if I have this networking piece, it's really easy to, it's unavailable, so switch to the other one. Really easy, like a real time without any kind of extra configuration, right? So it's just some highlights that we can use other tools and other things to empower this GenAI serving in your game.
Yep. And the last one is just availability of TPUs, GPUs. In order to make these things performant, certainly some models run on CPUs, and you can do that where it makes sense in GKE cluster or even in managed solutions. But also on Google Cloud, you have the option to integrate several GPUs as well as TPUs wherever it makes sense, depending on the type of model and use case that you're trying to target. All right, so with that, we had several folks that contributed to the GitHub repo. We'd also invite anyone else, if you're interested in contributing, you can take a look, test it out. And many more updates should be coming as well. So thank you all for your time. And we wanted to ask to please fill out the survey post-session. And let's see, I think that's it. So thank you very much and appreciate you coming.
Thank you all.